Okay, so like I said, we're going to continue to build off of those previous two scripts where we figure out how to make that uniform height and slope. Then the next one we looked at how to start to taper it down. And now we're going to add another layer to this process by having multiple points with differing heights. So now we can have a lot more control over our different earth mounds. And so you can again see where now we're using multiple of those points on curves. We're using that to basically parse out that data so that we can have all the points that are closest to that one, this one, and that one respond independently by having their own unique heights. And it gets a little bit more kind of uh, um, branched out with data, which we have to kind of bring back, which isn't the most difficult thing, but there are some added steps to that as well. So let's go ahead and get started again. We can build off of that previous script pretty easily. So the first thing we want to do is again, add multiple of these. So the one thing I am going to suggest is that as you add them, that you want to kind of um, have your next number to the right of this. So have it somewhere greater than 0.27. So Control C, Control V. I'm going to hold Shift to join that. Like I said, I want to have this one at a value. And then every time you add one, you want to continue to make sure that that height or that value is slightly higher, right? So make sure that it's kind of in that order, right? So this is the first one, second one, third one. That's why I kept it in that order, and making sure that those numbers are somewhere in between. So you can see by doing that, it does start to divide them. Um, but now we want to be able to have their own kind of designated heights. And so we have to actually um, parse out that data a little more. It's not as easy as just Control C, Control V, and saying, okay, now I want this to be that height, right? Like you have to actually graph those into separate branches of data. So in order to do that now, we want to take our closest point. We can see that we actually have our index of which points are with which index. So this is index 0, 1, and 2. And so if I go to sets and then this set part here, drag it in here, you'll see that it's looking at all our sets and which ones are designated with which. So from here, I'm going to go to math, operations, equality. And so this is again like all of our data points and which of these three indexes it's associated to. So you can see that there's first ones are all really close to that 0. And if I were to actually look at this, so basically again, looking at that giant grid of points of this entire planar surface, it starts to say which one of these is it closest to in terms of that index item. And so I can drag that into B. I'm going to drag this into A, but I'm going to graft it so that way it starts to actually separate. It starts to separate that data. So I'm going to shift this stuff over because now we're going to have a pattern to say, okay, is this point close to this one, true or false? This point, true or false? This point, true or false? So we're going to use the dispatch component to start to actually separate everything based off of that specific pattern. So I'm going to go to sets, list, and dispatch. So we're going to use this equal as our pattern. So we can see now we have this dash line, meaning that the data has been um, branched out. And now we can use the distance as our first list item. So we're going to use their A's and we're just going to replace that into here. It's going to look a little crazy for a little bit, so I'm going to actually turn this off for now. hopefully nothing crashes by starting to do stuff, so I'm going to disable some of these things. So I'll use the same dispatch components. I'm going to copy and paste it, use the same pattern because this is what's really going to control everything, but now replace it with this value and join this new list A into this. So everything's, again, for this dispatch, we're using the same pattern for all of them. We're just replacing the list, so we're looking at the distance list, the profile list, and then we're also going to do a list for the specific points. So we have geometry, we have profile, and we have distance as our different list items. And we'll turn this one off as well. So now we can actually start to add multiple sliders. So I'm going to do Control C, Control V, join that into there, Control C, Control V, join and add that into there. And now I'm going to graph them. So that way we know that there's 3 branches. You can see that when I hover this, there's 3 list items. There's 0, 0, then 0, 1, and then 0, 3. So 3 of those. And here's our 3 that get grafted to match that property. So now we can actually start to visualize that a little bit better. Now I'm going to turn this on. You'll see right now they're all at the same height, but I know that this is that first one. So if I start to drag that, now that one's lower. This one can be a little bit lower, I guess. Let's make that one there. Make this one higher. So now we start to independently control those different points associated with it. So here's the other kind of tricky part for making this into a surface, is that we've really kind of manipulated the data and like separated into these different groups. We kind of have to return it to that original list of points, right? So in order to do that, we need to find out the item index that we messed with in terms of its original pool. So I'm going to go ahead and flatten this and drag this into here. And now you'll see all those actual original index items that we've manipulated. Believe that's it. Yep. Let me just double check real quick. Yep, that was right. And so now I can actually replace those items from this process. So we have the original points. We have this new geometry that we're replacing it with. So I'm going to go ahead and flatten this as well. And then it's asking for that index item. So I'm going to grab that and join that into there. And now you can see if I turn off all of this, it all looks like it's merged together. Now all I have to do is replace that into there. Let's enable this, turn this off, turn this back on, and now we've got our 3 separate mounds with their own unique heights. And again, same kind of thing as what we did before, where we can adjust what that profile might look like. Maybe these are a little bit too narrow now, so I can always increase this span to be maybe out to 4. I can then adjust how I want them to taper off. Are they more sharp and pointed like that? Or do they have more of kind of a square end? Makes it very kind of interesting with this kind of almost stepping platforms. But I try to want to make it a little bit more elegant, I suppose. So you can see that they all kind of nicely, as they get towards the end, um, recede back into the original topography or that planar surface. Again, we can always adjust and move them as we see fit. So there you go. Now we've got their own kind of separate things working off of each other. And if you want if you want them to kind of take up more, you can always adjust that cap as well. But again, I like to see what that end product is. So let's go ahead and enable this. And there's the topography for it. So you can kind of see that there's these saddles in between as they kind of go down and then come back up. Um, but yeah, now we've got our own kind of independent uh, tapering heights for our surface. So this is pretty much going to conclude how to do these with these uniform slopes on either side using a center line. We'll stay in a very similar topic for another video, but instead of now having them be a uniform slope on either side of that center line, we can actually start to adjust to say maybe one's more steep and then the other one could be much more gradual. So now we can start to have some fun with that and obviously apply some of these same and similar principles to that process as well.